Welcome back. My name is Professor Hudson, and we will now continue with our narrated lecture on Chapter 2, Atoms, Molecules, and Life. This narrated lecture will cover Section 2.2, How do atoms interact to form molecules? Let's begin. Reactions between atoms give rise to molecules. Molecules consist of two or more atoms from the same or different elements that are held together by interactions among their outermost electron shells. When atoms react, they form chemical bonds, which are the attractive forces holding atoms together in molecules. Some of the bonds that you would see in molecules are covalent bonds. Also, some molecules are formed from ionic bonds. And hydrogen bonds are bonds formed between two different molecules. For example, hydrogen and oxygen are linked together to form water. The bond linking the oxygen with the hydrogen is a covalent bond. Table salt is an example of an ionic bond. The positively charged sodium ion is attracted to the negatively charged chlorine ion. Ionic and covalent bonds are bonds between atoms within a molecule. Hydrogen bonds are weak bonds between atoms of different molecules. This figure shows the molecular formula for glucose, which is a sugar. This molecule contains 6 carbons, 12 hydrogens, and 6 oxygens. This is how you would write the molecular formula for glucose. This figure lists some of the common types of bonds with examples. As mentioned already, ionic bonds consist of bonds between ions. Table salt is an example of a molecule formed from ionic bonds. Covalent bonds, there's a sharing of electrons between atoms. Some example of molecules formed from common covalent bonds are hydrogen, gas, and water. We'll talk more about water and hydrogen bonds in some upcoming slides. Let's take a closer look at how ionic bonds form. Atoms bonded via ionic bonds have gained or lost electrons. Atoms that have lost or gained electrons, thereby altering the balance between protons and electrons, are charged. They are called ions. In ions, the number of protons and electrons are no longer the same, thus giving the ion a net positive or negative charge. Atoms that have lost electrons become positively charged ions, sometimes called cations. An example of a positively charged ion would be sodium. Atoms that have gained electrons becoming negatively charged are sometimes called anions. Chlorine, in this example, is an example of an anion. Oppositely charged ions that are attracted to each other are bound together in a molecule by ionic bonds. The ionic bonds formed because of an attraction between the positively charged cation and the negatively charged anions. Opposite charges attract. This is now in contrast to covalently bonded molecules where the electrons are shared. Neither atom has gained or lost electrons. They are sharing them. They are both holding the electrons at the same time, so to speak. Covalently bonded atoms share electrons. If the sharing is equal, it is called a nonpolar covalent bond. If the sharing is unequal, we call it a polar covalent bond. Because biological molecules must function in a watery environment where ionic bonds rapidly dissociate, which means break down, the atoms in most biological molecules, such as those found in proteins, sugars, and fats, are joined by covalent bonds. This slide lists some common elements found in living organisms and the number of electrons in the outermost shell. As mentioned previously, the electrons in the outermost shell ultimately determine whether the atom will react with another atom. If the outermost shell is full, the atom will not react. If the outermost shell is not full, it will react. And we define full as the first shell can hold up to 2, and the second shell can hold up to 8. Water is an example of a molecule that is formed from covalent bonds between oxygen and hydrogen. As stated previously, covalent bonds have sharing of electrons. If the sharing is unequal, we say the molecule is polar. Water is an example of a polar molecule. The slightly positively charged pole is around each hydrogen, and the slightly negatively charged pole is around the oxygen. While the oxygen and hydrogen are sharing electrons, the sharing is unequal. The heavy oxygen is trying to steal all of the electrons from the hydrogen. They are sharing the electrons, but the sharing is not even. This is what's causing the slight positive charge around the hydrogen and the slight negative charge around the oxygen. We've talked about covalent bonds and ionic bonds. A third type of bond that was mentioned was the hydrogen bond. Hydrogen bonds form when a slightly negative atom in one molecule is attracted to a slightly positive atom in a nearby molecule. Hydrogen bonds are attractive forces between polar molecules. Now let us review. Remember, as you answer each question in the narrated PowerPoint lectures, jot down the letter that corresponds to the correct answer, as you will enter that letter in the Blackboard lecture quiz for this chapter. Question 6. Hydrogen bonds form when? Choose the correct answer. Question 7. In ionic bonds, which of these is true? Choose the correct answer. Question 8. The calcium ion, written as sodium plus, which of these is true? Choose the correct answer. One last topic we will talk about for section 2 of chapter 2 involves free radicals. Some cellular reactions produce free radicals. A free radical is a molecule in which atoms have one or more unpaired electrons in their outer shell. Free radicals are highly unstable and reactive. Free radicals steal electrons, destroying other molecules. Cell death can occur from a free radical attack. You may have heard about free radicals, as certain green vegetables contain chemicals that help to reduce the likelihood of free radicals forming in the cell. These vegetables and some fruits are thought to protect against cancer because they reduce the likelihood of free radicals forming. This will conclude section 2.2.